Lesson 3. Moments and Frameworks. Now we turn our attention to moments and frameworks. The moment of a force about a point is calculated by multiplying the force by the perpendicular distance from the point to the line of action of the force. For example, a system of coplanar forces can be reduced to a single resultant force. The moment of this resultant about any point will exactly equal the total moment of the original system of forces. You can find a perpendicular distance to the resultant's line of action by simply dividing the total moment by the resultant's magnitude. When solving problems involving uniform rods or beams, remember that the weight of the object acts exactly at its midpoint. If a rod is hinged at one end and held by a string or supports at the ends, you can find unknown tensions and reactions by taking moments about the hinge or a support. We also analyze forces inside smoothly jointed frameworks. A rod carrying a tensile force is in tension, meaning it pulls on the joints at each of its ends. Conversely, imagine a vertical load is applied downward at a joint and supported by a vertical rod. That rod must provide an upward force on the joint to maintain equilibrium. Therefore, the rod is in compression, providing a thrust equal to the downward load. Understanding the difference between tension pulling on joints and thrust pushing on them is key to mastering framework problems.